Find the value of x and y to the nearest tenth. Okay, so here we have a right triangle. We're given one angle and one side length. So that means we can't use the Pythagorean theorem because for that we need two sides. But we have trig. So we're going to use our trig functions. We have to figure out which one applies. So it's always right on top of this problem, SOHCAHTOA, so you can figure out which one applies to this problem. Okay, so with respect to this angle, this 34 degrees, the 8 is an opposite. Okay, so let's find x. X is the hypotenuse of this triangle. You can see it's opposite of the right angle, so the hypotenuse is always opposite the right angle. Okay, so if we have opposite and we have hypotenuse, we look at SOHCAHTOA and we notice that this is the sine function. Okay, so we set it up. Sine of 34 equals opposite, which is 8, over hypotenuse, which is x. So now we solve for x. So let's multiply both sides by x, because the x is on the bottom of the fraction. We want to get it to the top, so let's multiply both sides by x. So we're going to get x sine of 34 equals 8. So the last thing to do is divide both sides by sine of 34. So x equals 8 over sine of 34. So this is the time to whip up your calculator and plug this in so you can figure out the answer to this. So let's do that. So this is approximately what? Okay, so I punched it in my calculator and it came out to 14.3. Okay, so that's the length of x. Okay, so we still have to find y, and I'm still going to use the opposite, because if I use the rounded value that I just found, our answer is going to be less exact, although it's still acceptable to use that. I prefer to just use the thing that will make it the most exact. So this time 8 is the opposite and y is the adjacent. Okay, so let's look at SOHCAHTOA, and we notice the one that has opposite and adjacent is TOA, which means we need to use tangent. So tangent of 34 equals opposite over adjacent. So 8 over y. And again, we use the same method to solve. So multiply both sides by y. Y tangent of 34 equals 8. And divide both sides by tangent of 34. So y equals 8 over tan of 34. Okay, so again, we need to plug this in the calculator. So let's do that real quick. Okay, so that comes out to 11.86, so 11.9. And remember, you need to have your calculator in degree mode when you're dealing with degrees, otherwise you're going to get the wrong answer. So make sure you set it to degrees. So these are our two answers. We rounded to the nearest 10. Okay, let's take a look at the second example. Okay, so again we have a right triangle, an angle 65, a side length 12, and the 12 this time is the hypotenuse. Okay, so again I'll write SOHCAHTOA. Okay, so since we have the hypotenuse, immediately you notice that tangent is probably not going to be the one we're going to be using, since that does not have hypotenuse. So let's find x with respect to that angle, to that 65. You can see that the x is opposite to that angle. So if we have the opposite and the hypotenuse, that means we're going to use sine. So sine of 65 equals opposite, which is x, over hypotenuse, which is 12. Okay, solve for x. So we're going to get 12 sine of 65 equals x. Okay, so this is the time to punch things in the calculator, so let's do that real quick. Okay, so we get that x is about 10.87, so 10.9. Okay, so the y. Okay, with respect to 65, the y is adjacent. You can see it's right next to the angle. Okay, and again, we're going to use the 12, which is the hypotenuse. So this time we're using cosine. So cos of 65 equals adjacent over hypotenuse. So multiply both sides by 12. So we have 12 cosine of 65 equals y. Okay, now again, punch things into the calculator and get an answer. Okay, and so I got 5.07, so 5.1 is our answer.